So level 1 problem, determine the components of the reactions at A and E if a 750 Newton force directed vertically downward is applied at B, then letter part B at D. So if the 750 Newton downward force is directly applied at B, then CE, member CDE, is a two-force body because there's no load in between. So remember the principle of two-force body, the forces at the pins will be directed to each other and collinear, equal also. So this is the FBD at A. We expect two reaction components also at E. But we simply replace the reaction at D by a single force which passes through C because it is a two-force body as shown. Then the angle here that RE makes with the horizontal is arctan of 75 over 250, 170 plus 80. So the angle is 16.699 degrees. So to solve for EH, we set moment at E0, then counterclockwise positive, so EH times 200 mm, then minus 150 times 80, 750 times 80. So AH can now be solved. If it is positive, that's correct. Remember, these are external reactions, and in the free body diagram, that would be final, if positive. So 300 newtons leftward, then we cannot solve EV, so we solve for RE first. We set moment A0, or R horizontal 0, to solve for RE. So RE cosine of 16.699 degrees minus EH, which is 300. So RE can now be solved. 300 over cosine 16.699 degrees, 312.21 newtons. So therefore, E horizontal is RE cosine of 16.699, the horizontal component of RE, and it is rightward. So R sub EH is equal to 300 newtons rightward. So that checks. If you consider the whole system, then summation forces horizontal is 0. Then E vertical is RE sine of 16.699 degrees. So E vertical is equal to 90 newtons upward. Finally, set vertical component of resultant 0, whole system. So REV vertical, which is AV, equals E sub V, which is 90, plus E sub V, then minus 750. Substitute the value of EV, which is 90, so 0 equals 90 plus A vertical minus 750. So A vertical is 750 minus 90, so it is equal to 660 newtons upward. So that's it. That's the complete solution to this problem. Then for part B, not yet finished. So 750 is now acting at D. So this time, it is member ABC, which is the two-first body. So the reactions, component reactions at D, let's assume the direction shown. And also, do not just assume, you just anticipate the direction. Anyway, if you do not think of that, then you just put two reaction components, then just analyze. Then if they are positive, the direction, assigned direction should be correct. If negative, then you just reverse it. But make sure that the static equation is correct. So this time, RA is a, or member AC is a two-force body. That's why the reaction at A passes through C. In the same manner, the reaction at C passes through A. Then the angle here is now, with the horizontal, is now arctan of 125 over 250. It is equal to 26.565 degrees as shown. So to solve for RA, we set moment E0. So there are two components, horizontal and vertical, but the vertical component passes through E, so only the horizontal component. counterclockwise positive. So this is RA cosine of 26.565. The moment arm is again 200. Then minus 750 times 80. Then we can solve RA with magnitude 335.41 newtons. So that the horizontal component of reaction at A, EH, is leftward. It is equal to 335.41 cosine of 26.565. So AH can now be solved. It is equal to 300 newtons leftward. Then A vertical is RA sine of 26.565. So 335.41 sine of 26.565. It is upward and it is 150 newtons. Then RH0. So EH equals EH minus R minus AH, which is 300 leftward. So AH is also 300 but rightward newtons. And finally, R vertical equals 0. So we have E 150 A vertical plus E sub V, then minus 750. So E sub V is 750 minus 150, so it is 600 newtons upward. So that's the complete solution to this problem.